Hydrogels can be found in many variations in our kitchens and food products. There are wobbly jelly, gummy bears, or a more modern food, bubble tea. Our question here is, what are hydrogels molecularly and how can we make them? Hydrogels are cross-linked polymer networks. Here you can see a section of a water-based polymer solution. This polymer solution is normally a thick, viscous liquid. Examples of such polymer solutions can be thickeners, commonly used for cooking. A hydrogel polymer network, however, is more complex. Here the polymer chains are being cross-linked with each other. This drastically alters the texture or consistency of the polymer solution. It becomes a semi-solid, as shown in this video. Here, a jelly is dropped onto a surface and we can see how it deforms upon collision. At the beginning it looks like a liquid splashing, but when the jelly bounces back we can see how it retains its initial shape. This is because the cross-linking of the polymer chains forces the structure to remain in its shape. Not to make it too complicated, but the origin of this problem comes from entropy, the driving force of chaos in the universe. Now let me show you how we can make bubble tea based on the hydrogel technique. What you see here in the background is water in which many small calcium ions swirl around. We now add a droplet of a viscose sodium alginate solution, our template for the polymer network. The calcium ions act as crosslinkers when they meet the alginate polymer chains. Just as in the last slide, they bind the alginate chains to each other and make them become a hydrogel. Of course, this cross-linking starts from the outside of the hydrogel droplet, but the calcium ions try to penetrate deeper inside. However, on their way inside, they encounter alginate chains and undergo the cross-linking reaction. The more the alginate chains become cross-linked, the more impermeable becomes the hydrogel. At the end, this leads to the formation of a hydrogel shell around the droplet that does not allow further calcium penetration. The calcium ions bounce back and we have obtained a droplet with a solid shell but a liquid interior. This interior can contain tasty flavors. The special mouthfeeling, however, comes from the core shell structure. Biting these hydrogel spheres lets the shell burst, upon which the tasty content is being released into the mouth.